Okay, hopefully this is recording. We're getting a little better at it. We are up to the binomial series or expansion, and it's basically focused on dealing with a binomial x plus y to any power. Now, ordinarily on this particular problem, we could get there by just merely saying x plus y times x plus y times x plus y and times x plus y, which is a bit of a hassle. It's a lot of work. It's a lot of, if you want a bit, foils to do, or whichever way you want to do it. But there is another way. It's called the binomial expansion to do this thing. The first thing is an interesting pattern. Without giving you the formula, the pattern is easier to know than taking the formula for the binomial expansion, plugging in the numbers, and getting the result. So it's composed of two parts: getting the terms of when you multiply all this, and then there are coefficients. So we're going to do the terms first. Just try to follow the pattern. With this type of a thing, you raise x, that whole quantity, whatever x is. That could be 5w, anything like that. It's still treated as a whole quantity, and two whole quantities added being a binomial. So we have x to the fourth, then it's y to the 0, which is just 1. Then we add to it x to the third, we reduce it, but then all of a sudden y pops up, y to the 1. Notice 3 plus 1 is 4, and 4 is the same there. And then x squared, y squared. 2 plus 2 is 4, we verify that. And then plus x to the 1, y cubed. Again, 3 plus 1 is 4. And then it's x to the 0, which is 1, times y to the fourth, and it ends there. So here's the basic part of the expansion, done very easily by really a routine that involves patterns. It's obtained by a more general formula that you can find in books, but exactly why do it that way, I'm not sure. So this way seems to be easier, and they're both with non-understanding. The formula we don't understand except if we created it, and this series we don't understand. In any case, what about the coefficients? They're missing stuff, as it turns out. Well, the coefficients here can be obtained by two ways. One is by combination notation, which we'll get to after this, and the other is Pascal's triangle. Now, Pascal's triangle, let me put that over here. Pascal's triangle is a series of numbers that, again, by patterns alone, without understanding how he came up with it, why he came up with it. I hate that, but we sometimes have to do that until we have the time and desire to really research why did he do this thing, how did it come about, what is the meaning of it. Okay, in any case, the triangle looks like a triangle. There's a 1 in the beginning, 2 1s, and I'm going to put some other 1s in here. 1 plus 1 is 2. You add the middle together. Then I'm going to put 2 more 1s. 1 plus 2 is 3. 2 plus 1 is 3. And we have 1, 2, 3, 4, 5 terms. So I have to go one more row, 1 and a 1 over there. 1 plus 3 is 4, if you see what I'm doing. And 3 plus 3 is 6, and 3 plus 1 is 4. So here's the part of Pascal's triangle, which goes on forever, that we are concerned with. Now these numbers, 1, 4, 6, 4, and 1, are the coefficients on these terms. So therefore, x plus y to the fourth power should be 1 times x to the fourth, which is x to the fourth, plus 4 times the next thing is 4x cubed. I don't need y to the 1. I can merely say y. 6 times the next guy, x squared, y squared. And then 4 times the next guy, x to the 1 is x, y cubed. And then 1 times the last term. So this is the official expansion. Excuse me. I'm going to sneeze, or shall I say I have sneezed. All right. So that's what they want you to do for the problem, essentially. Now I'm going to flip back. Excuse me for a second. I have share screen on here. Okay. We are up to number 14, which I will do as 2x minus 1 to the fourth power. So let's get back. Stop share. Okay, so now we're back to the story, and I got from your sheets number 14. Let me see if I can get this a little straighter. And let's see, I think that's the focus, isn't it? I don't know. In any case, let's do this one. This one, the first term of the binomial is 2x. The second term is -1. So let me rewrite it this way. 2x in parentheses plus a -1 in parentheses, the whole thing to the fourth power. So that's the first step you'd have to do to get it into a form that we can expand. Let's go ahead and expand it now. This equals the whole 2x to the fourth power and y, which is -1 to the 0 power, which is still just 1, plus the whole 2x to the third power, and then the little old y, if you will, pops up with a second term, -1 to the first power, plus 2x squared -1 squared, plus 2x to the first power -1 to the third power, and lastly, plus 2x to the 0 is 1. It's just -1 to the fourth power. Okay, so that's your first step. That's without the coefficients, mind you, but we want to now make it a little prettier, if you will, before we layer on the coefficients to this. So 2 to the fourth power is 2 times 2 is 4, 4 times 4 is 16. This equals 16x to the fourth power, plus -1 to the 1 is a minus, so it's not a plus, it's a minus. 2 times 2 is 4 times 2 is 8, 8x cubed. Then this guy over here is, I got a 4 from that, and this is a positive, so it's plus 4x squared. And then plus, this over here is a minus sign, so again, I screwed up, it's a minus, not a plus. And that's 2 to the 1 is 2, you get 2x. Then lastly, -1 to the fourth power is a plus, and it's a +1. So here it is cleaned up a bit, what we just had before. We have to layer the coefficients onto this to get a full binomial expansion. So we, again, use Pascal's triangle, trying to get down to the 1, 2, 3, 4, 5 terms. So let's do it together. You get 1, 1, 1, 1, 1, and then you start. 1 plus 1 is 2. And now we've got 1, 1, 1 plus 2 is 3. Oh, you're not seeing this, are you? Okay, and then 2 plus 1 is 3. That goes with that. That only gives you 4 terms. We have 1, 2, 3, 4, 5 terms to do. So one more, 1, 4, 6, 4, 1. And that's the one we're going to use, kind of like before, because we have in the original 1, 2, 3, 4, 5. Before, if you notice, we had 1, 2, 3, 4, 5, the same 5. So that's why we're at this level of the Pascal triangle. So this problem ends up being 1, that's that 1, times 16x to the fourth. Then it's 4 times that. 4 times 8 is 32, so it's -32x to the third. And then it's plus 6 times 4, or 24x squared, minus 4 times that is 8x, and then lastly still only a +1. So this is what you would get if we took 2x minus 4 and multiplied it out 4 times in the regular way that we do it with FOIL or whatever other method you want. You will get 16x to the fourth minus 32x cubed plus 24x squared minus 8x plus 1. Okay? And this is just, since we're only dealing with patterns here, we're not plugging and chugging in formulas really. It's a little easier than doing 2x minus 1 times 2x minus 1, get that result, times 2x minus 1, get that result, times 2x minus 1, get that result, and you would get the same thing. Okay, excuse me for a second. I got to go back to share screen mode so I can see what I'm doing next. All right, that was number 14. Now we have, we've got quite a few of them. I'm going to write it down on the side so I don't have to keep going back and forth. Let's go with 6 factorial, 6 factorial over 3 factorial. It's quite a few of them. 5 factorial over 1 factorial. 6 factorial over 4 factorial, 2 factorial. A 3 with a C and a 1, a C with a 2 and a 2, and lastly a C with a 4 and a 3. You don't know what I'm talking about because you don't see it right now. I'll show you in a second. So that was 20 through 32 even is what I'm doing. Alrighty, next, let's go back to the screen. Stop sharing, and we're back live. Okay. So what this one is to evaluate factorials, which we need to use with the binomial to do it yet another way. Instead of Pascal's triangle, you can do it with combination notation, which demands that we know how to deal with factorials. So that's what this is about right now, dealing with factorials. So the first problem is, what in the world is 6 factorial? Well, 6 factorial is just progressing downward. 6 times 5 times 4 times 3 times 2 times 1. And that's 30. That's 120. And 120 times 6. 120, whoops. 120 times 6. It looks like it's 720. So that's the value of 6 factorial. Got it? Raise your hands. I can't see you, so it doesn't matter. All right, next. 6 factorial divided by 3 factorial. Well, here the trick to evaluate it, given that's what a factorial is to break up the 6 factorial, expand it to the highest denominator, in this case 3 factorial. And the way we do this is the following. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Well, 3 times 2 times 1 is 3 factorial, so I can just write times 3 factorial. Why do I want to do that? It's less writing because we have a 3 factorial underneath it, and they cancel. So your end answer ends up being 6 times 5 is 30, times 4 is 120, and that's your answer to that baby. Okay, next. 5 factorial over 1 factorial is just, well, 1 factorial is 1. So it's going to equal 5 factorial, which is 5 times 4 times 3 times 2 times 1, which is 20 times 3 is 60. 120 it looks like to me. We catching on? I hope we are. All right, let's do the next one. It is 6 factorial over 2 factorials, 4 factorial, 2 factorial. Okay, the way we examine that or evaluate that, so we expand the 6 to the highest factorial down below. So 4 factorial is the highest one, so I'm going to go 6 times 5 times 4 factorial. That's the same thing as 6 factorial. It's just called expanding it down to the 4 factorial part of it. And now I'm going to place that 4 factorial underneath it so I can cancel. And 2 factorial is really just 2. You don't need the 1. 2 times 1 is 2. So we cancel this out. The 2 goes into 6 3 times, and you get an answer of 15. Not that terrible. Okay. I'm just checking it off. We then have we have 3 combination notations, but I'm going to make one up which will represent all of them. So the made up, let's say made up, I'm going to put a C with arbitrarily eeny, meeny, miny, mo. Let's say 7 combination 4. Okay, that's what that is. Now, this notation is also the same as 7 with a 4 underneath it, no line, and 2 parentheses. It's pronounced 7 combination 4. And it is interpreted as, and you're doing this just by patterns. There's no sense even having a formula once you see it. You put the first thing, the 7, as a 7 factorial. The second one goes underneath. So far, so good. But there's something missing here, and that missing is you go 7 minus 4. So I'll write it down for you. Factorial. So this ends up equaling 7 factorial over 4 factorial times 3 factorial. Please note the pattern that 4 plus 3 is 7. Doesn't mean anything other than it's a pattern. Okay, now I'm going to expand the 7 factorial down to 4 factorial. 7 times 6 times 5 times 4 factorial over. Put the 4 factorial lined up. 3 factorial is 3 times 2. I don't need the 1. I can cancel this. 3 times 2 is 6. 7 times 5 is 35. and that is your answer. Okay? So we did all those. This is page 1. Okay. We don't have much today to do, but it'll give us a break. It's the last thing we're doing for the semester. Thank God. Page 2. Okay, I still have to go back again. I wonder if there's an easier way to do this. Let me see. Oh yeah, that's another way. Okay, so what I'm looking at is, if I can get it, number 38. Oh, that's C10-6. All right. So I'm going to go ahead and do number, what did I say? 30? Oh, shoot. I forgot. Let me get that. It's number 38. And I don't know what that last one was. I'll get it in a second. Number 38. C10-6. Okay? So it's this combination notation. Firstly, I want you to know that's the same notation as 10 combination 6. And that's going to be 10 factorial over 6 factorial. But then 10 minus 6 is 4 factorial. So that's the way to do it faster. I'm going to expand the 10 down to the 6. 10 times 9 times 8 times 7 times 6 factorial. I'm going to line up the 6 factorial underneath it so I can cancel that and expand the 4 factorial to 4 times 3 times 2. I don't need the 1. It doesn't matter. Now, 4 times 2 is 8, so I can get rid of that. 3 into 9 is 3. And I get 10 times 3 is 30, times 7 is 210, and that's my answer. That is what 10 combination 7 is, 210 ways of juggling things around, whatever it's used for. We just need a little bit to know how to deal with this notation. Okay, let me go ahead and do yet another one. Number 40. Oh. Number 40 is m plus n to the 5th power equals. All right, so let's do this thing. Okay, so we have number 40 is m plus n to the 5th power. Now, it looks like we certainly could do it like we did before, but we're going to see another pattern, which is interesting, that you're supposed to know. So again, I'm first going to expand it by the terms, and we have m to the 5th power, n to the 0, so I don't have to do anything with that. I have m to the 4th power, n pops up on the screen, n to the 1 power, m to the 3rd power, n squared, m squared, n to the 3rd power, m to the 1st power, which is just m, n to the 4th, and plus we have m to the 0, which is 1, times n to the 5th. So here's my initial expansion made up of 1, 2, 3, 4, 5, 6 terms. What we do is we use the combination notation to fill in the coefficients. And we start with the combination 5, combination 0. So under here, I'm just going to put it under so you can see the pattern. 5 combination 0 will go out there. 5 combination 1 will go out there. 5 combination 2, whoops, put his line shouldn't be there, will go out there. 5 combination 3 will go out there. 5 combination 4 will go out there. And 5 combination 5 will go out there. All right. So we know what it is. It's a matter of calculating, well, what is it? Now, this turns out to be the same thing as the Pascal triangle. But let's compute it and see the comparison between Pascal so you know it is. Excuse me while I cough my brains out. I'm going to take a lozenger. It's a COVID cough. I have no idea what it is. Been having this on and off for the last month, but it wasn't really COVID. I had a whole coughing thing last summer. And I don't have a fever, so I'm not contagious, so don't worry. Or otherwise I'd send the bug over the computer and it'd get you all. Okay. All right, so number 40 over here, right? So let's figure out 5 combination 0. That's going to be 5 factorial over 0 factorial. 5 minus 0 is 5 factorial. These 5 factorials cancel. You get 1 over 0 factorial. And I forgot to mention that just like with powers where you have, let's say 10 squared is 10 times 10, 10 to the first is 10, 10 to the 0 is, what is it? 10 to the 0 is 1 if you said that, okay? Well, the same thing with factorial notation. Out of the necessity of the math, 0 factorial has to equal 1. So 0 factorial equals 1 out of mathematical necessity. Okay, so that's equal to 1. So therefore, this has to equal 1 over 1, which is just 1. And that'll go in front of the m to the 5. What about the next guy? Let me see, where am I? Oh, 5 to the 1. 5 combination 1. Breaking that down, actually it's the formula, but we're doing it by patterns. 5 factorial over 1 factorial, 5 minus 1 is 4 factorial. Breaking this down, 5 times 4 factorial, and 1 factorial is just 1, I don't even need it in there. Cancel that off and you get 5. That goes in front of this term, okay? 5 combination 2 equals 5 factorial over 2 factorial. 5 minus 2 is 3 factorial. Breaking it down to the maximum underneath it, which is 3. 5 times 4 times 3 factorial over 3 factorial. That's why I did that. 2 times 1 is just 2, and you get 10. That's what that is. There, that's 10. 5 combination 3 is equal to 5 factorial divided by 3 factorial, and 5 minus 3 is 2 factorial. That's the same thing as the other one, so it better come out to be the same. So that's going to equal 10. Don't even have to think about it. And that's what this is, 5 combination 3. 2 more. 5 combination 4 equals 5 factorial over 4 factorial. 5 minus 4 is 1 factorial. Notice that's the same as this guy over here, and therefore it got to equal 5. There's a little symmetry going on here. And lastly, 5 combination 1 is 5 factorial divided by 1 factorial divided by, 5 combination 5. That's 5 factorial divided by 5 factorial. 5 minus 5 is 0 factorial. The factorials cancel, you get 1 over 0 factorial. Just like we had before, the answer is 1. Okay, now let's notice Pascal's triangle if we did it. 1, 1, 1, 1, 1 with a 2, 1, 3, 3, 1, 1, 4, 6, 4, 1. How many do we have? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. This is the 5th thing. We need one more. 1, 5, 10, 10, 5, 1. Now look at that and look over here. 1, 1, that's check. 5, the next one is 5, 5, that's check. 10, 10, yep. Another 10, another 5, and another 1. That was a box around my 1. So we've just verified that Pascal's triangle, using that, is equivalent to using the other thing. It's just more elegant to have combination notation. It also, computers can do this where computers really don't work this out that well. You have buttons on computers that do these combinations and give you the right answer. So it's actually nice that way. Okay, so what do I want to say about number 40? So the final answer with the numbers in there are m plus n to the 5th is m to the 5th times 5 combination 0, which is 1, so you still get m to the 5th. 5 combination 1 is 5 times m to the 4th, n to the 1st, that's just n, plus the second guy is 10. 10 times m cubed n squared, plus it looks like we have 10m squared n cubed, plus we have 5 times m n to the fourth, plus we have 1 times n to the fifth. So here is your final expansion. Done the coefficients, the basics are the same. This first expansion is the same in both cases, but what we did is we included the combination notation to get the coefficients, because that's a little more efficient if we had larger numbers and we used the calculator which had those things on it, as opposed to Pascal's triangle, which you'd have to work out by hand. With small things, it's easy to do. Anyway, that's number 40. Any questions? Raise your hand. No questions. Amazing. All right, so let's do, I think it's the last one. Let me just work that out and put this down. And yes, the last one. X squared minus 1 cubed. X squared minus 1 cubed. And that's number 40, I think. Okay, I got to look at it again. It is number 44. See, I was wrong. This one was 40. What am I doing? Oh, yeah, I did have it. Number 44. And there was another one with the things. I might as well look at that. This was number 20, 22, 20 through 32. So let me write that down. Number 20 through 32, odd. No, even. That was, I didn't do that before. Okay, I think I'm okay now. All right. Last problem of the semester, this crazy COVID semester. So I think we should actually have a little applause or something. I wish I had that on the gun, but let's, yay, last one, yay. I hope you're doing that at home. So let's see if we can do this. Now, first term here is x squared. That whole thing squared, that's like x or m, like the m plus n. And the last one is minus 1. So I'm going to do the first expansion. First expansion says x squared cubed times minus 1 to the 0 power, which is 1. Then the next expansion is x squared squared, and then this pops up minus 1 to the 1 power. Then the next one is x squared to the 1 power minus 1 squared. And the next one is x squared to the 0, that's number 1, to the minus 1 to the 3rd power, and that's where it ends. So now we have to clean this up a bit and layer on the coefficients. I don't know which way you want to do it, the combination notation or the Pascal. Let's do it Pascal, it's easier, all right? So Pascal triangle gives us 1, 1, 1, 1, 1, that's a 2, 1, 3, 3, 1, 1, 4, 6, 4, 1. We have 1, 2, 3, 4 terms, so we're actually worried about that guy over here. Okay? So this becomes equal to 1 times x squared cubed, which is x to the 6th power. This guy is 3, but it's a minus. Minus 3 times x to the 4th power. Then the next guy is another 3. This is plus because it's minus 1 squared is 1. So it looks like it's another 3x squared. And then we have plus minus 1 cubed, which is a minus 1, so I didn't want a minus. So minus 1. Okay. And that becomes your expansion of this binomial, which we could have gotten those other coefficients, 1, 3, 3, 1, by saying, let me put it over here, 1, 3, 3, 1 could be implied by, you start with the pattern as you start with the high power 3 and do 3 combinations, 0, 3 combination 1, 3 combination 2, and lastly 3 combination 3, giving you the four values of Pascal, except it's done in combination notation. Okay, so that's it. Page 2 for the day. We are done. Hooray. Hurrah? Hooray? Hooray with the Y, right? Or hooray. There you go. End of semester. All right, so I'm going to get off of this, and I will be giving you the, as usual, the, what do you call it? The Tiny Scanner app, and there's a video with YouTube. Then you'll have to wait a little while to get the video recording that we're doing, which is really the lecture notes. So you can look at it on the side. What I advise you to do is either have it on the screen, on the side. Well, it has to be on the. You have to have either 2 computers, or you got to print out the lecture notes, and then you can play the one that you just saw and kind of go along with it to get better help, as if you have an instructor in front of you. So that's what I advise you to do. And I want to know how it's turning out. Okay, so let me go ahead and I don't know how to end it. How do I end this thing? Well, that's kind of fun. Oh, stop video. Maybe that's it. Pause. No, pause recording.